Hello, my dear students. We are going to be discussed about 10 plus 2 chemistry, unit 1, solid state. So let's introduce about solid, liquid, and gas. These are the state of matter. So we are going to be discussed about solid state. Solid state are the most ordered state. They have fixed volume, fixed shape. They are rigid, and they have strong intermolecular forces of attraction. There is an competition between intermolecular forces and thermal energy. So, if intermolecular forces predominates, then the matter exists in the solid state. If the thermal energy predominates over intermolecular forces, then it is liquid or gases. So, in case of solid, they have tightly packed. There is least space between them. They have strong force of attraction between themselves. They have no compressibility. So these are the characteristics of solid state, which is given here. Solid have definite mass, volume, and shape. The intermolecular distance in solid are short and intermolecular forces are strong. Constituent particles in case of solids, atom, ion, or molecules have fixed position. They can only oscillate about the mean positions. Solid are almost incompressible and rigid. The density of solid is greater than the density of liquid and gases. Solid diffuses very slowly as compared to the liquid and gases. Most solid become liquid when heated. The process is known as melting, and the temperature at which solid change into liquid is called melting point. Melting point of solid depend upon the nature of solid, which vary widely. Classification of solids. So you can see that here this thermal energy, there is a competition between the thermal energy and intermolecular forces. So solid, liquid, and gas. Solid can have only vibratory motions. So you can just say there is no any motions in case of solid. Their axis में ही इनका motion रहेगा. Classification of solids. Next topic. Number 1, crystalline solids. Substance whose constituent particles, atom, ions, or molecules are arranged in a definite geometric pattern in three-dimensional space are called crystalline solids. Next one, these are long range order because the constituent particles are arranged systematically with a long time with equal manner. Amorphous solids. Second one, the substance whose constituent particles are not arranged in a regular arrangement are called amorphous solids. These are short range order. So these are the, here is the example of crystalline and amorphous solids. Here is crystalline quartz, this is quartz glass. So you can see here crystalline quartz में arrangement atom ion और molecules का equal है, लेकिन in case of amorphous quartz glass there is irregular arrangement. After a small interval arrangement is disturbed. So this is amorphous solids. You can say that here is the difference. There is some property. Number 1, geometry. So definite regular geometry have crystalline solids, while amorphous have not definite geometry. Melting point, crystalline solids have definite melting points, sharp melting point you can say, whereas amorphous solids have a wide range of melting points. Isotropy and isotropy. Crystalline solids is show an anisotropy, while amorphous solid is isotropic in nature. You can say that isotropy have which have same physical property in all directions, जो कि amorphous solids द्वारा शो की जाती है, और anisotropy होते हैं फिजिकल प्रॉपर्टी डिफरेंट इन फिजिकल प्रॉपर्टी इन डिफरेंट डायरेक्शन, जो कि क्रिस्टलाइन सॉलिड्स द्वारा शो की जाती है. These are the some properties. तो Here is an example which you can just understand very badly. So here all the examples on order of arrangement of constituent particles, shape you know very well, melting point, enthalpy of fusion, cleavage property. तो crystalline solids clear cut cleavage होगा, जबकि amorphous solids का irregular cleavage होगा. Anisotropy, crystalline solids show anisotropic in nature, while amorphous solids are isotropic in nature. Crystalline solids are true solids, while amorphous solids are pseudo solids और supercooled liquids. Example यहाँ पे आगे silver, copper, iron, common salt, zinc sulfide, potassium nitrate, while amorphous solids have example glass, rubber and plastic etc. These are the examples. Classification of crystalline solids. We study about crystalline solids furthermore. So here is some classifications of crystalline solids. Number one, molecular solids. These are the crystalline substance in which the constituent particle are molecules. They may be two types. Number one, non-polar molecules, or second one is polar molecules. Non-polar molecules, there is less electronegativity difference, like noble gas helium, neon, argon, etc. For example, solid helium, solid argon, etc. Iodine, they are generally soft, they have low melting point, they are usually in liquid or gaseous state at room temperature. They are non-conductor of electricity because they consist of neutral molecules, solid as well as dissolved state. Polar molecules, polar molecule, we have some substance by polar covalent bond like HCl, solid SO2, solid NH3. They are solid and are also soft, non-conductor of electricity, low melting point, not very high melting and boiling point, room temperature and pressure conditions. So you can say that third one is hydrogen bonded. You can see that molecules such as like water, which have bond between themselves with highly electronegative elements F1, फ्लोरीन, ऑक्सीजन, नाइट्रोजन. हाइड्रोजन इज एसेंशियल, हाइड्रोजन बॉन्ड बनाएगा F1 के साथ. फ्लोरीन हो सकता है, ऑक्सीजन हो सकता है, नाइट्रोजन हो सकता है. दे आर जनरली वोलेटाइल लिक्विड्स, सॉफ्ट सॉलिड अंडर रूम टेम्परेचर, normal pressure condition. Second, they are non-conductor of electricity. Third, their melting and boiling point are generally higher than those of the non-polar molecular solids and polar molecular solids. Second was ionic solids, the solid which is formed by the ions, the cations and anions. For example, NaCl. They have electrostatic force of attraction between themselves. Ionic solids are very hard and brittle. They have very high melting and boiling point. They are poor conductor of electricity, therefore are insulated in solid state, while in aqueous dissolved state they conduct electricity. So these are the properties of ionic solid. Next one is the metallic solids. Metallic crystal may be hard as well as soft. They are good conductor of heat and electricity. They have melting luster and color in certain cases. They are malleable and ductile due to malleable nature. They can be beaten into sheets and drawn into wires. They have moderate enthalpy of fusion. Common metals such as nickel, copper and alloys. Covalent or network solids. You can see that crystals which forms covalent bond. Covalent crystals are hard. They are extremely high melting points and may even decompose before melting. They are poor conductor of electricity and insulator. Example आपका आ गया क्वार्ट्ज, डायमंड, ग्रेफाइट, सिलिकॉन कार्बाइड, कार्बोरेंडम भी बोलते हैं, बोरोन नाइट्राइड etc. These are the property of covalent or network solid. You can just differentiate between diamond and graphite, which is very important. Diamond is sp3 hybridizations, while graphite is sp2 hybridizations. There is an diamond is hardest substance, graphite is softer one due to sliding of their layers. Graphite is good conductor of electricity, while diamond cannot conduct electricity. So these are the exception property of graphite is this one soft है, good solid lubricant के काम आता है. Here is a chart which describes that molecular solids have weak force, that is dispersion or London force. Example H2I2CCl4CH4. And in case of polar, there is dipole-dipole interactions. In case of hydrogen bonded, here is a force of attraction, that is hydrogen bonding. Ionic solids में strong electrostatic force रहती है. Example NaCl, MgO etc. Metallic solids में metallic bonding रहती है between kernel and positive ions and electrons. Here is all the metals which form bond, that is metallic bond, covalent bond which is formed by the atoms, electron sharing pairing से जो बॉन्ड बनता है, सिलिकॉन डाइऑक्साइड, सिलिकॉन कार्बाइड, डायमंड एंड ग्रेफाइट. These are the covalent or network solid. This is all about the classifications of crystalline solid on the basis of nature of bonding. Next one, crystal lattice or space lattice. As we know very well, there is an imaginary space position of particles relative to one another are usually shown by points. The arrangement and infinite set of these points is called space lattice. The position which are occupied by the atom, ions or molecule in the crystal lattice are called lattice point or lattice sites. Two-dimensional lattice, regular arrangement of constituent particle in a plane. You can just say that there is an two-dimension unit space lattice. Three-dimensional crystal lattice, इसमें यूनिट चला जाता है. Crystal lattice, the regular arrangement of the constituent particles, atoms, ions or molecules of a crystalline solids in a three-dimensional space. This is known as crystal lattice. And unit cell, smallest unit, three-dimensional repeating portion of a space lattice which when repeated over and again in different direction produces the complete crystal lattice. This is known as unit cells. Parameter of unit cells, you can say that there is an parameter, two parameter of unit cells. Number one, edge length, which is A, B and C may not be mutually perpendicular. Second one is the angle alpha, beta and gamma between the pair of the edges. The angle alpha is between A and B, beta B and C and gamma C and A. Characteristics of crystal lattice. Each point in a crystal lattice is called lattice point or lattice site. Second, each point in a crystal lattice represent one constituent particle which may be atom, molecules or group of atom or ions. Third one, the three-dimensional arrangement of lattice point repeated represent crystal lattice. Lattice points are joined by straight line to bring out the geometry of the lattice. Type of unit cell, primitive and non-primitive. Primitive unit cells are unit cells which have point or particle only at the corner. These are called simple unit cells. Non-primitive unit cells, center unit cell. These are the unit cells which have points at the corner as well as at some other positions. These are further divided into three types: face center unit cell, body center unit cell and center unit cell. Face center, the atom is present at the corner as well as at the center of each face. Body center unit cell, in which the points are present at the corner as well as at the body center of the unit cells. And center unit cell, in which the points are present at all the corner and at the center of the two opposite faces. These are the non-primitive type of unit cells. Here is an 7 crystal system. You can say that when unit cell in a crystal lattice, simple or primitive unit cell can be arranged. The atom whether atom size, as length, or angles can be varied, then we can find out the 7 type of crystal structure, that is CTO में ट्रेन रुकी है: cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral, triclinic. You can just see here, cubic is the most symmetrical, while triclinic is the most unsymmetrical system of crystal lattice. So these are the structure of 7 crystal system of primitive unit cell type or simple unit cell type. You can just see here that there is a variation between the angle as length and angle in case of different structure, which constitutes 7 structure. Just see here diagram that with example cubic NaCl and KCl, tetragonal, tin, calcium sulfate, and orthorhombic, rhombic sulfur. You can just see monoclinic sulfur, and sodium sulfate. Next one, hexagonal, graphite is hexagonal, rhomboidal, calcite or cinnabar is rhomboidal, triclinic, copper sulfate dot 5s2 is triclinic, potassium dichromate, orthophosphoric, boric acid S3BO3, all these are the triclinic. So with example you can learn one example, and which is very important. Type of cubic lattice: simple or primitive, body center cubic unit cells, face center cubic unit cells. These are the simple unit. Here is in body center cubic. Next one is the face center cubic cells. So here you can say that here is in 14 type of Bravais lattice. You can just say that CTO में ट्रेन रुकी है, तो here is a 7 primitive unit cell type. Then these primitive unit cell further be primitive body center, face center. You can see that in case of cubic there is 3 types. In case of tetragonal, primitive is present at almost in all the structures, all the 7 types. In addition to that, these also show body as well as end center as well as face center. You can see that in case of orthorhombic, primitive body center, face center and end center, all type of unit cell, it shows all type of arrangement of unit cells. So you can say that orthorhombic have 4 type of unit cells, while monoclinic have 1, hexagonal have 1 also, rhomboidal have 1, triclinic also have 1 type of unit cells. There are 7 crystal system and 14 Bravais lattice. You can just see that these arrangement. So these are the arrangement of unit cell in 14 Bravais lattice. Here we can find out the atom per unit cell. One atom, 8 sides they can occupy. One atom can cut into 8 equal parts. Then 1 upon 8 part of that atom can contribute to in a 1 unit cells. So we can say that the contribution of the each atom to the unit cell is at the corner is 1 upon 8. At the face, second diagram you can see here 1 upon 2. Within the body, third diagram you can see that is 1. So you can find out the atom per unit cell in case of simple or primitive unit cells. 8 corner into 1 upon 8 atom per unit cell. So there is the value of Z is 1, that is 1 atom per unit cells. नेक्स्ट वन इज़ द बॉडी सेंटर यूनिट सेल्स. कॉर्नर का कंट्रीब्यूशन 1 रहेगा, एक बॉडी के सेंटर में होगा उसका भी 1 रहेगा. देन जेड की वैल्यू कितनी हो जाएगी 2. टोटल नंबर ऑफ एटम इन बॉडी सेंटर क्यूबिक अरेंजमेंट इज 1 + 1 दैट इज 2. नेक्स्ट वन इज़ द फेस सेंटर क्यूबिक यूनिट सेल्स. तो कॉर्नर पे एटम प्रेजेंट होगा जिसका कंट्रीब्यूशन 1 रहेगा. 8 कोने हैं, 8 × 1 अपॉन 8 दैट इज़ 1. एंड 6 faces, 1 face का contribution of 1 upon 2. Then you can calculate that 6 × 1 upon 2 atom per unit cell is equal to 3. Total contribution 4. Next one, this is here is an calculations. There is a relationship between the nearest neighbor distance. You can say that radius and as length. Here is a difference between radius and Here is atom relationship between number of atom relationship between A, that is as length, and R, radius of the atom of the cube, unit cells, and packing efficiency of the unit cell. In case of simple unit cells, as below variable as length is equal to A, 8 atom we have done, Z की value 1 है, then per unit cells relationship between A and R, वी कैन जस्ट से कॉर्नर पे 2 आइटम लेंगे, उसका जो डिस्टेंस रहेगा R प्लस R रहेगा, A इज इक्वल टू 2R. नेक्स्ट वी कैन कैलकुलेट पैकिंग एफिशिएंसी. यू कैन से दैट पैकिंग एफिशिएंसी इज द पोर्शन और फ्रैक्शन covered by the atom in a unit cell is called packing efficiency or volume occupied by atom in unit cell. Packing efficiency is equal to volume of atom present in unit cell upon total volume of unit cell into 100. This is Z into 4/3 pi r cube upon a cube into 100. Packing efficiency is equal to Z की वैल्यू सिंपल के लिए 1 है, which we have done previously, और एटम का एक स्फीयर होता है, उसका वॉल्यूम 4/3 पाई आर क्यू होता है. ए इज इक्वल टू 2R है, तो ए का क्यू की जगह 2R का क्यू आ जाएगा. देन वी कैन कैलकुलेट हियर विच इज 3 पाई की वैल्यू 3.142 इंटू 100/6. तो दिस इज पैकिंग एफिशिएंसी इज इक्वल टू 314.2.6 is equal to 52.4% in case of simple cubic unit cells. This is vacant space of voids is 47.6, which is unoccupied space. Next one is the body center cubic unit cells. So you know very well this is the arrangement of body center. Z की वैल्यू बॉडी सेंटर के लिए 2 हो जाएगी, 1 एक सेंटर में रहेगा और दूसरा ए का कंट्रीब्यूशन कोने का रहेगा. Here Z की वैल्यू 2 and relationship between A and R. A is the length, R is the radius. You can say that radius is equal to 4R in case of body center because there is 3 atom arranged diagonally, that is body diagonal. We can find out radius which is equal to root 3A. Root 3A because the base which we have calculated that is root 2A. बेस का एक डायगोनल है, उसमें हमने रूट 2 निकाला बाय यूजिंग पाइथागोरस थ्योरम. ए इज सेकेंड साइड्स एंड एच इज हाई लॉन्गर साइड्स हाइपोटेन्यूस. बाय यूजिंग दिस वी कैन कैलकुलेट अंडर रूट 3A विच इज इक्वल टू 4R. पैकिंग एफिशिएंसी सेम फार्मूला विच वी हैव यूज्ड प्रीवियसली. Z की वैल्यू 2 एटम पर यूनिट सेल. दिस इज द 4/3 pi r cube is the volume of a sphere upon a cube is the volume of atom. ठीक है, into 100 which is efficiency which is equal to 68% in case of BCC. You can see here void or vacant space that is 32%. Phase center cubic unit cells. In case of phase center cubic unit cells, that is face diagonal, not body diagonal. Here is face diagonal. फेस डायगोनल में हमारे पास 3 एटम आएंगे, आर की वैल्यू सेम 4R रहेगी और रूट 2A इज द वैल्यू ऑफ एज लेंथ इन केस ऑफ ट्रायगोनल बाय यूजिंग पाइथागोरस थ्योरम. रूट 2A इज इक्वल टू 4/√2R बाय यूजिंग हियर इक्वेटिंग √2 से दोनों साइड गुना करने के बाद हमारे पास 2√2R इज इक्वल टू 2√2R विच वी कैन यूज हियर इन केस ऑफ पैकिंग एफिशिएंसी. Z की वैल्यू हमारे पास है सी हियर 4. Z की वैल्यू 4 है इंटू 4/3 pi r cube that is the volume of sphere into 100 upon 2√2R 3 times मल्टीप्लाई करोगे 16√2R cube cancel. Then by cancellations we can get pi into 100 upon 3 into √2. Root 2 की वैल्यू 1.41 we will put here. We can calculate that which is 74%. This is the packing efficiency of FCC 74%. In case of simple, 52%. In case of VCC, 68%. In case of FCC, which is 74%. So the order is here. FCC have greater packing efficiency as compared to BCC as compared to SCC. So this is the calculation of packing efficiency in case of simple body and face center cubic unit cell. So this is all about. We have done this one and we have done all these things previously. Here is in some type of packing, how we can pack the atom or constituent ions or atoms in a crystal lattice in different manner. Number one, close packing structures. So these are the close packing on dimensions. Coordination number is 2. You can just set in one row whether it is x axis में ही हम पैक करेंगे. क्लोज पैकिंग इन 2 डायमेंशन, 2 डायमेंशन करेंगे तो इसका कोऑर्डिनेशन नंबर भी बढ़ जाएगा विच इज इक्वल टू 4. We can pack the constituent atom or science in the x and y axis. This is 2 types of packing. One is square planar packing, square close packing. Second one is hexagonal close packing. In square close packing, one atom is placed above the other in 2 rows in 2 directions and coordination number is also 4. Or in hexagonal close packing, one atom is placed in between the 2 atoms. The space is between the 2 atoms. So you can just say the coordination number hexagonal close packing is 6. So we will just move to further, that is close packing in 3D. All crystalline solids have 3D structure. These can be obtained by stacking 2 डायमेंशनल लेयर वन अबव द अदर. 3D में अब 3 प्रकार की ए टाइप 3D स्क्वायर पैकिंग होगी. स्क्वायर पैकिंग वी हैव डन दैट वी हैव स्टडीड इनिशियली दैट वन एटम इज प्लेस्ड अबव द अदर. तो 3 रो हमने लगा दी, एक्स एक्सिस, वाई एक्सिस एंड जेड एक्सिस. कोऑर्डिनेशन नंबर विल बी 6. दिस इज 3D and in both these cases AB type or ABC type. Here you can say that here is 2 types of voids vacant space. One is tetrahedral voids. The void which is present between the 4 atoms is known as tetrahedral void. The void which is present between the 6 atoms is known as octahedral void. So initially tetrahedral voids will produce to cover that tetrahedral voids. Octahedral voids will produce. So like that AB type packings we can pack, and then tetrahedral and octahedral voids will produce such type of packing is known as AB type packing. Or ABC, 3 different layer is present, and which is in case of FCC or CCP 3D packings. You can see here tetrahedral voids is 2n and octahedral void is n. Type of void in FCC which we have shown here, which is 8 is tetrahedral void and 4 is octahedral void. We can see here in case of FCC coordination number 4, then you can see here that octahedral void कहाँ पे प्रेजेंट होगा, बॉडी के सेंटर पे और एज के सेंटर पे. बॉडी के सेंटर पे एक होगा which we can see here in case of body center. Here is octahedral voids and बाकी एज पे होगा. एज पे यहाँ देखिए एज पे है here you can see here एज पे ये octahedral voids अपर वाली साइड पे है. नेक्स्ट वन इज द tetrahedral voids which is present at the corner. तो 8 tetrahedral voids हो गए, 3 और 1 4 octahedral voids हो गए. तो we can say that the number of the tetrahedral void is always double to that of the tetrahedral octahedral voids. ठीक है, tetrahedral voids का जो नंबर है हमेशा डबल रहेगा एज कम्पेयर टू octahedral voids. We have done all these things. Here is last is that is radius ratio. This is the ratio which is present in the atoms. You can see that cation, arrangement of cation and anion, cation with respect to anion. If the radius ratio lies between 0.155 to 0.225, which coordination of it has coordination number 3. You can see that here is triangular planar example B2O3. Next one 0.225 to 0.414, coordination 4 tetrahedral, example zinc sulfide. 0.414, 0.732 is 6, that is octahedral, example NaCl. 0.732 to 1, coordination number 8, body center cubic, which is example is CSCl. You can say that by knowing the radius ratio, you can find out which type of crystal is present, whether it is tetrahedral, whether it is octahedral, whether it is body center. Z4 FCC4 you know very well, BCC के लिए 2, simple के लिए 1. If you want to calculate the density, that is during gym, no questions. Z is the atom per unit cell, M is the molar mass, and naught is the Avogadro number. एक is the as length or volume of a unit cells, you can say that. Next one is the defect in crystal lattice. One is stoichiometry, second is non-stoichiometry. Stoichiometry cation and anion का ratio equal missing होगा. Non-stoichiometry there is unequal missing of cation and anion. We will study about the stoichiometric ratios in case of which is further divided into two types, Frankel defect and Schottky defect. फ्रैंकल डिफेक्ट में क्या होता है, कैटायन मिसिंग होता है नॉर्मल साइड से एंड ऑक्यूपाई इंटरस्टिशियल साइड्स, और जबकि शॉटकी डिफेक्ट में इक्वल नंबर ऑफ पॉजिटिव एंड नेगेटिव आयंस मिसिंग फ्रॉम नॉर्मल साइड्स. तो यहाँ पे डिस्प्लेस फ्रैंकल में डिस्प्लेस होगा, शॉटकी में मिसिंग होगा. तो डू नॉट चेंज डेंसिटी, फ्रैंकल में डेंसिटी चेंज नहीं होगी, जबकि शॉटकी डिफेक्ट में डेंसिटी डिक्रीज हो जाएगी. दूसरी चीज़ है फ्रैंकल डिफेक्ट उन एटम, उन क्रिस्टल लैटिस की जिनका कोऑर्डिनेशन नंबर कम होता है, जबकि शॉटकी डिफेक्ट उनके द्वारा शो किया जाता है जिनका हायर कोऑर्डिनेशन नंबर होता है. NaCl है, देयर इज एन ऑक्टाहेड्रल which is octahedral structure which is coordination number 6, NaCl, CSCl, AgBr, जबकि फ्रैंकल डिफेक्ट में AgCl, AgBr, AgI और ZnS. तो यू कैन से दैट AgBr एक ऐसा क्रिस्टल स्ट्रक्चर है जो कि दोनों डिफेक्ट शो करता है, फ्रैंकल एज वेल एज शॉटकी डिफेक्ट. डिफेक्ट होता है डिसऑर्डर और डेविएशन फ्रॉम कंप्लीटली ऑर्डर अरेंजमेंट ऑफ कंस्टिट्यूएंट पार्टिकल इन ए क्रिस्टल इज कॉल्ड डिसऑर्डर और डिफेक्ट. थैंक यू, हैव ए नाइस डे.